Good evening, welcome. Sabuj, Priya, welcome, guys. I'm good. I'm good. How are you? How's everyone? So, basically, let's wait for your friends to join in, and then we are going to start practice today. So, this is our first session of practice on my channel. Right, so we are going to be discussing some really good basic questions of organic chemistry. Okay, so for example, yesterday only I told you that you can just revise a little bit. We'll start from the basic and then we are going to move onwards. Okay, so yeah, how is everyone? सब कोई जुड़ जाते हैं, उसके बाद करेंगे प्रैक्टिस शुरू. या पहले बताओ, रिवाइज किया था? Yes, practicing questions. Yeah, who's laughing? हाँ मैम, आप जो बोलोगे हम वैसा ही थोड़ी ना कर लेंगे, इतना आसान थोड़ी है. Isn't it? All right, yeah, let's just wait for 1 more minute for everyone to join and then we are going to start the practice. Practice के बीच में सब लोग आते रहेंगे. Right. Yeah, Priya, you have also started understanding Hindi, isn't it? Very good evening to all of you guys who are joining. Very, very good evening. So I have kind of decided that this timing is good. What do you say? ये time ठीक है सबके लिए? 6 p.m. 6 p.m. to 7 p.m. 1 hour practice. Good evening, good evening. What is today's topic? You see, basic organic. Ekdam basic. Good evening, Shubhadeep. Welcome. Okay. Yes, guys, very good evening. So, please tell me if this timing is okay for all of you because I think ki 1 hour practice we can do daily on a daily basis. Either we are going to do some practice or we are going to do some revision. जो भी in demand होगा, जो आप लोग request करोगे, वही हम कर लेते हैं. Let's say today we are doing practice. Today is Sunday. I know Ganesh, there's a match going on. I know that as well. But let me tell you that there are many things which are going on. In my house also, there are many things. Navratri chal rahi hai, and this is actually festival time at my home. Everyone is enjoying, but I am really dedicated to all of you guys, and that's why I'm here. So, match को 1 घंटा postpone कर दो. Advanced level question net or gate के देखो, yeah, learner definitely first we start from the basic and then we move onwards to the advanced level. Absolutely. So yes guys, chalo theek hai, let's start our practice. Let's not delay any further. So today I've taken some very basic questions, and then from tomorrow, see, I just wanted to know that how your response is going to be. Based on that we are going to move onwards in our sessions. ठीक है? So because this is my channel and everything that happens on this channel is going to be based on what you ask me to do and what I can do for you. Okay, there is no interference from anybody else. So that is why I just completely want the content to be useful to my students or my subscribers. So please inform me, and inform me on Telegram, inform me on YouTube, on Instagram, wherever you want to inform me. Okay? Yes. So that's it, guys. Question number 1, very simple. Major product formed in the following reaction is. अच्छा, वैसे ही एकदम basic है. Okay. So basic of general organic chemistry, basic of reaction mechanism, everything. Absolutely. Yes, AChem, very good. What about the others, guys? अच्छा, देखो, आंसर करो, कुछ भी हो आंसर करो. Okay. So you said radical mechanism, which is correct. लेकिन उसके बाद में अगर हम radical mechanism, see, as soon as you see NBS, and what is this? Is it benzol? See, benzoyl peroxide, which is going to break down in the presence of heat, ऐसे करके. Okay, so that the radicals are going towards oxygen. So you're correct till here कि benzoyl peroxide है. It is going to give you benzoyl radical, two of these. Then what happens? It is going to give you carbon dioxide, which is going to eliminate. और ये क्या बन जाएगा? pH radical plus CO2 निकल जाएगा, right? So you have got a radical. Very good. Radical initiator, absolutely. So radical initiator in the presence of heat or light, ठीक है. Now, whenever you are doing the radical reaction, you are never going to do bromination on the aromatic ring. Never, ever, ever. Why? Because radical kahan stable hota hai? Radical is stable on the side chain, isn't it? Radical is stable on the side chain. Why? Because now if it forms on the side chain, it is going to do resonance within the ring. If the radical forms on the ring itself, it is not electrophilic aromatic substitution. तो यहाँ तो बिल्कुल नहीं बनेगा radical, absolutely wrong. So all of these options where the bromination has taken place on the ring, everything is wrong. Okay, so it's a simple radical reaction with the stable radical formed on the kind of benzylic position. Yeah, allylic bromination या benzylic bromination. Yes, Srijita, एकदम. Chalo, second question, guys. Awesome question. The correct match of C13 NMR chemical shift value ppm for pyridine is. अब देखो ये भी basic है. Even if you don't know NMR, then also you can answer if you know basic stuff. This is an actual basic question based on electron distribution within the molecule of pyridine. Yes, Saboj and Akem, just a little bit more careful. Pyridine का dipole moment किधर जाता है? Dipole moment of pyridine goes like this, downwards towards the nitrogen. However, the dipole moment for five-membered molecules like this, it is going up in the upward direction. You got it. So which means that because it is pulling the electron density, according to de-shielding concept option 4, but you know option 4 में बताया है that C2 is the ortho or basically just the next carbon over here. This is C2, then there is C3 and then there is C4. Okay, so if we are actually selecting this option, you have fallen into a trap. गलत है ये सही नहीं है guys. Why? Because when you are doing resonance, you see resonating structures are like this. Negative आया, positive, like this. Now when you do one more resonating structure when you're writing, so it is going to be like this, negative, positive on the fourth position. So every time when you are doing resonance, the C3 position is always having electron density, this side or this side, but C2 and C4 are having the positive charge. Yes or no? So option number 4 is wrong. It is not correct. ठीक है, तो कौन सा correct है? Yes. C2 is absolutely the most de-shielded. Why? C2 is correct. अगर हम बोलेंगे C2 150, then it is correct. Most de-shielded because positive charge, minus I as well as the minus M effect of the nitrogen. ठीक है, correct. But C3 is actually less de-shielded than C4. C4 is more de-shielded. तो answer C है इसका. 3 answer है इसका. Got it, everyone? Yeah, it is a very, very important concept. You must know that regular de-shielding nahi hai. irregular deshielding, the ortho para position, or let's say the 2 and the 4 or the 6 position, these are all more deshielded as compared to the 3 and the 5. Chalo, very good. We move onwards to another question. Correct order of rate of thermal decarboxylation of the following compound. Yes. All right. Very well. Rate of thermal decarboxylation. This is a little bit tricky. ऐसे सारे question tricky होते हैं. All right. Very good. Okay. Let's think for one more second and answer. All right. Correct order for rate of thermal decarboxylation. So basically, thermal decarboxylation, we're just heating and eliminating carbon dioxide. No reagent is provided. Fine. So what are we supposed to do over here? Let's take option number C. It is like this, for example. या मुझे इसको थोड़ा सा ऐसे लिखना चाहिए. That this proton is going to be attracted by nitrogen, and the removal of charge is very simple over here. Why? ऐसा क्यों है? क्योंकि अगर हम इसको यहाँ पुट करते हैं, then this electron density is actually stabilized like this. Or let's say if you want to write it like this, it will be good. You can just have your pyridine back, and it is CH2 negative. ठीक है, या फिर CH3 भी लिख सकते हो. ठीक है. So C is going to have the decarboxylation at very much ease because the proton is attracted to nitrogen. Also because if you are considering the negative charge, it is very stable at this position. Or if you are considering how the electron density is going to shift, the best possibility is when you are having one carbon in between the pyridine ring and the carboxylic, because it becomes like the benzylic position. With having minus I and minus R effect, yeah, minus M effect of the nitrogen. Both of these are working over here. Best example. Now in option number B, if such thing happens, see, in the second one, if we are trying to do the same thing, ये देखो same चीज करेंगे. All right, let's say we are considering the negative charge. It will be easier if we consider the negative charge. So what happens? यहाँ पे negative और lone pair तो है ही. So nitrogen has a minus I effect, which is going to be better than simple benzene nucleus, because nitrogen has a minus I effect. But there is repulsion between the lone pair also. So it is going to be weaker than C. C is the best, and it is going to be better than A, because A के पास कोई भी effect नहीं है. Nobody attracting the electron density. So the answer is option number A. Right. So जिन्होंने भी A answer किया था, congratulations, A is correct. ठीक है? Yes, let's move onwards. No, 4 cannot be the answer because of B. Okay? चलते हैं? Next, similar question. Now, correct order of basicity of the following anions. Now, I have many a times when I was teaching on an academy, my students will know, I have given you a very short trick to answer this question, that PKA is directly proportional to basicity All right. Greater the basicity, greater is the pKa. You will understand this when we answer. Okay, try it on your own. केबीसी टाइम बिल्कुल। बात वो है कि अब कोई जीत भी जाता है तो उसको करोड़पति का चेक नहीं मिलने वाला है। हाँ, बिकॉज तुम लोगों को करोड़पति का चेक देने के लिए मुझे करोड़पति होना पड़ेगा ना पहले, तो उसमें बहुत टाइम है अभी। ऑल राइट। ओके। ऑल राइट, वेरी वेल, वेरी नाइसली आंसरिंग गाइस। ऑप्शन 4 दिस टाइम, या दिस टाइम वेरी श्योर कि हाँ 4 को लॉक कर दिया जाए। ठीक है, चलो। सो ऑलराइट, सी एक्चुअली देयर आर टू डिफरेंट कैटेगरीज ऑफ कंपाउंड। ये अलग कैटेगरी है और ये अलग कैटेगरी है, इजंट इट? Unstable anion is more basic. Yes, you can go that way also, or you can just go that way that okay, more stable anion is less basic. तो दोनों सेम ही चीज है। ठीक है, पर एक बात, अगर हम थोड़ा सा जैसे पीके का आइडिया हो गया, लेट्स से वी हैव अ लिटिल बिट ऑफ आइडिया ऑफ पीके, देन ऑल्सो वी विल बी नॉट कहीं पे रुकावट नहीं आएगी, विल बी एबल टू आंसर नाइसली दैट what happens when we are considering the molecules CH3NO2, the actual acids, okay, and CH2 या फिर CH3CN, अगर हम इन दोनों में से देखें which is more acidic, तो it is so obvious that this is going to be more acidic, right? अगर कई बार ऐसा होता है कि कई बार नहीं भी आता है हमें कोई आंसर डायरेक्टली स्टेबिलिटी ऑफ बेसिस को देखकर, then we can go on the acids. Stability of base is greater for this one, and this is less stable because less electronegative atom over here. So what is the order of basicity? Order of basicity is like this. इसका acidity order ऐसा है, तो इसका basicity order ऐसा है. B is going to be more basic than A. These are two different compounds. They are not aromatic. Aliphatic है. Second option यहाँ जो second choice है, these are aromatic in nature, in which this is a carboxylic acid and this is a phenol, isn't it? ये तो phenol है और ये तो carboxylic acid है. So ज़्यादा acidic कौन होगा? Which one is more acidic? Carboxylic acid or phenol? But this is trinitrophenol actually. Yes, ट्राइनाइट्रोफेनॉल है ये, तो ये सिंपल फेनॉल भी नहीं है, दैट इज वाई कंपेयरिंग विद द एसिड. नाउ हियर इफ यू सी conjugate base is very very stable because it can give electrons into all of these nitro. सारे नाइट्रो के अंदर बहुत ज्यादा इलेक्ट्रॉन डेंसिटी जा रही है, डिस्ट्रीब्यूटेड 3 different नाइट्रो ग्रुप्स. So isn't that great? This is going to be very stable. If this is stable, this is going to be less basic as compared to D. So D is going to be more basic than C. And if I put these two together, तो ये वाला जो section है, this is a more stable section. ठीक है, as compared to the aliphatic ones. So definitely the aliphatic ones are going to be less stable and more basic as compared to these two. So answer is option number 4. Yes, picric acid common name है इसका, बिल्कुल सही. And yeah, picric acid is more acidic than simple carboxylic acid. चलो आगे चलते हैं. अब देखो, IUPAC nomenclature, everyone hates it, but still we have to do it. And specifically in gate examination, CSIR तो फिर भी इतना नहीं पूछता, gate is definitely after IUPAC. So what do you think? Which one is the most beautiful option? क्वेश्चंस आर वेरी ट्रिकी. अरे ये ट्रिकी नहीं है, ये इजी है, इसको बेसिक बोलते हैं सीएस एंड नेट का. दिस इज बेसिक ऑफ सीएस एंड नेट. बट यू नो the level is going on increasing, I know, and that is why we might feel कि डिफिकल्ट होता जा रहा है. बट ये जो पूरा क्वेश्चन पेपर है ना, उसमें से सबसे इजी क्वेश्चन लेकर आई हूं मैं. इजीएस्ट. ऑल राइट. सो या, everyone has to answer. ओके, जस्ट फॉलो वन थिंग. लोएस्ट सम रूल बोल के एक चीज होती है. डू यू रिमेम्बर lowest sum rule, that from wherever we are doing the numbering, we must have the lowest number in combination. सबसे lowest number आना चाहिए, isn't it? Yes. So for example, let's start numbering. If we are doing the numbering, right, double bond को पहले लेंगे, fine, correct. But from where, which end of the double bond? Let's suppose we are starting from here. 1 2 3 4 5 6, like this. If we are doing the numbering, 1 पे ethyl है, 2 पे प्रोपाइल है, एंड 6 पे methyl है. So what is the total of this? Yes, what is the total of this, guys? 15 आ गया, 15. Okay, we have one more option. We'll start numbering from here. 1 2 3 and 4 in this way. So we have 1 and 2 and 4 plus 4. कितना आएगा? 4 plus 4 is 8, plus 1 we have 11. So जो छोटा number आ रहा है, the smaller number that we are getting, will do the numbering from that side. That is the lowest sum rule in the IUPAC nomenclature. Very basic thing. So if we are numbering from here, 2 position पे आया ethyl, 1 पे आएगा propyl, 4 dimethyl, and what is this? Overall it is a 7-membered ring. It is going to be heptene. So you're just going to look at that. 2 ethyl देखना, 2 ethyl, 4 dimethyl, 1 propyl, cyclo, hept 1 ene. So yes, yes, exactly. That is why I explained that we have 2 different ways of nomenclature. उसमें से ये वाला correct है because it is giving us the lowest sum. So shall we move onwards? Option number B is the correct answer. जिसने भी option B बोला था, congratulations to all of you. आप करोड़पति तो नहीं बने हैं, but फिर भी correct है. ठीक है. All right. चलो, let's move onwards. Next good question. अभी ये easy है. Correct order of stability of the carbocation A to C. Three carbocations, which is the most stable, least stable? उससे आसान रहेगा. Yes, guys, this is the easiest question of today. ये आज का सबसे आसान क्वेश्चन है. ओके, डू वी रिक्वायर सो मच टाइम? बस हम कार्बोकेटाइन के नाम से ही डर जाते हैं, इजंट इट? एक तो IUPAC, स्टेबिलिटी ऑफ कार्बोकेटाइन्स, even if the question is very easy still. Yes, absolutely, guys. Easy. Very easy. Very good. Very good, all of you. Very, very good. Now, see, this carbocation option number C. This is having stability because of resonance. So it is going to be stabilized like this. Very easy. ठीक है. Most stable, this one. Why? Because in option number B, you are only having two hydrogen. क्या कर सकता है? ज़्यादा से ज़्यादा two hyperconjugation structure it can show. You remember alpha hydrogen hyperconjugation? All right, fine. So C is more stable than B. इतना तो देख लिया. What about A? A is most unstable because it is vinylic कार्बोकेटाइन which is very very unstable. sp2 कार्बन के ऊपर कार्बोकेटाइन है जो कि बिल्कुल भी स्टेबल नहीं है. Okay, because sp2 has a greater s character, that's why more electronegative as compared to sp3 orbital. So very correct answer is option number 4. Very good. Very 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 good, all of you. Yes, बहुत अच्छे से आंसर किया. अच्छा, दूसरे ट्रिकी क्वेश्चन पे आ जाओ. Following carboxylic acids undergo decarboxylation upon heating. Okay, ease of decarboxylation is in the order, again the same thing. Okay, ये दोनों option same है. A and B are the same from the previous question. There is C this time. All right. Just think a little bit more. Ganesh, only a little bit more. Almost there. Yes, very good, all of you. Very good. Keep going. Everyone has to answer. Guys, ये दोनों तो मैंने अभी बताया पिछले क्वेश्चन में. You cannot forget. Okay, just previously we discussed the same question, isn't it? Absolutely, guys. For those who are answering option number B, this is the correct option. See, it is so easy. How can we eliminate option? अगर आपको ऐसे नहीं आ रहा है कोई question कि how are we going to approach this question, which is the correct option, then just go with the elimination process, right? What does that mean? अभी अभी देखा था पिछले वाले question में that pyridine, even though there is repulsion over here when we are considering the anion which will be formed after decarboxylation like this. Okay, if we are considering this, pyridine is having some repulsion, but it is also having a minus I effect, which is going to still stabilize the negative charge as compared to benzene, which is having nothing. So B is going to be better than A. इतना तो for sure है. If you are sure about this, then cancel option number 3, cancel option number 4. Can we do that? We have always got to go with the elimination process. ठीक है, अब चलते हैं आगे. Either it could be 1 or it could be 2. What about C? See guys, यहाँ पे अगर हम इलेक्ट्रॉन, let's say if we are doing a decarboxylation, this carboxylic acid group is very far away from this nitrogen. Okay, so we cannot, let's say the nitrogen cannot help in removing the proton. That is not possible. लेकिन फिर भी, let's say it is O minus, let's say the electron density falls over here. What is going to happen then? Alright, there is a NH, okay, like this. So what is going to happen if there is electron density like this? First thing, there is no repulsion between the electrons. Electron repulsion तो बिल्कुल भी नहीं होगा. Also, there is a minus I effect of the benzene ring. नाइट्रोजन का माइनस आई, बेंजीन का माइनस आई इफेक्ट, लेकिन माइनस आर इफेक्ट अभी भी नहीं है. सो इट इज स्टिल बेटर as compared to B and A because of the minus I effect of this system and no electron repulsion. So this is the correct answer. चलो आगे बढ़ते हैं. बहुत ही सिंपल, इतना सिंपल क्वेश्चन. Synthetic equivalent of given synthon is. Now what is a synthon? Who knows? किसको पता है synthon किसको बोलते हैं? Yes. Yes, guys. What is a synthon? Basically, जिन आपने पढ़ा है सबने रेट्रो, बीएससी थर्ड ईयर में, एमएससी फर्स्ट ईयर में, एवरीवन हैज स्टडीड रेट्रो. सो ये रेट्रो का जीओसी है. ठीक है, दिस क्वेश्चन इज फ्रॉम जीओसी ऑफ रेट्रो. हाइपोथेटिकल स्पीसीज, सिंथेटिक इक्विवेलेंट. यस, सिंथेटिक इक्विवेलेंट इज जिसको हम यूज कर सकते हैं सिंथेसिस में. And synthon is basically just a charged fragment that we have made while doing the retro analysis of a molecule. Okay, right. So जैसे हमने retro analysis किया एक molecule का, and we have found this, that on the same carbon which is a carbonyl we need a positive charge and we need a negative charge. How is that possible? ऐसा कैसे possible है? एक negative भी चाहिए, positive भी चाहिए on the same carbon. In out of these molecules, which is going to give so? Yes. Okay, चलो ठीक है, एनालाइज करते हैं सबको. Tertiary butyl cyanide. So it is basically going to be like this, tertiary butyl cyanide. Okay, let's say you require a positive charge and a negative charge. तो यहाँ carbon is delta positive only, it is not negative. It is not negative, and when you are doing hydrolysis of cyanide, you might get the carbonyl, but you are going to get the carboxylic acid. But it is only having delta positive, delta negative नहीं है. Okay. अच्छा, tertiary butyl isocyanide अगर देखें तो what is how is a isocyanide written, guys? Already a triple bond, nitrogen got positive, carbon got negative. तो carbon पे negative है, और अगर ये इस तरीके से चला जाए यहाँ पे, one of the possible resonating structures, obviously it is not गोइंग टू बी रिटन लाइक दिस, ऐसा लिख नहीं सकते हम इसको, बट ठीक है, आपको समझ में आ रहा होगा that if one bond goes over nitrogen, then this carbon, this is going to have one positive one negative. इसको मैंने अगर हाइड्रोलाइसिस कर दिया, then I will get carbon positive negative and a double bond. Does it make sense what this hypothetical situation is about? Yes or no? Right. If let's say I'm having tertiary butyl isocyanate. Yes, yes. So tertiary butyl isocyanate, if somebody is going to react over this carbon, ये भी delta positive है because it is bound by oxygen and nitrogen on this side. So it is even if you are, let's say, breaking this bond down, you must get somebody to attack over it. ठीक है, और यहाँ तो ये एकदम सीधा सीधा बन रहा है, tertiary butyl isocyanate, directly you can see just one resonating structure I have drawn, nothing else. Okay, so directly on hydrolysis you will get this. Answer is option number A to this, guys, और बाकी सब गलत. ठीक है, तो ये किसका GOC है? रेट्रो का GOC है ये. ठीक है, चलो नेक्स्ट इजी क्वेश्चन. Correct order of the pKa of the following compound is. My voice is too low, is it? Everyone tell me. Is my voice very low? I think you can also try to turn up the volume of your device, Mohammed. All right. Yes, इरफान, थोड़ा सा एक बार दोबारा से देखने की कोशिश करो. All right, guys. Thank you. Okay, you have time, and it's a very simple question. So, कौन से concept पे question है? Basic. Correct order of pKa. Which concept is used? pKa means acidity or basicity. pKa means acidity. Okay, but pKa is, this equation will be given to you everywhere, but this equation, this correlation is not given to you. Okay, this you have to deduce by understanding. Why did I say so? Let's see this in this question. ठीक है. Yes. CNA becomes aromatic after loss of a proton, but see, we are losing a proton, minus H plus. So if you are removing a proton from here, minus H plus, that is going to give you a carbanion, isn't it, Arslan? ये तो carbanion देगा ना? And the same over here, if we are removing this proton, it is going to give us a negative charge over here. So A and C will become anti-aromatic. B is going to become aromatic, isn't it? चलो देखते हैं इसको. Acidity, whose acidity is going to be maximum? B is going to be most acidic, as compared to C as compared to A. ऐसा है? Is this so? This is the acidity order. Why is that so? Because B is going to become aromatic. This is having 6 pi electrons. This is aromatic. Okay. C और A anti-aromatic बन जाएंगे if they are losing a proton. So A is very small molecule and it is very strained already. So this is going to be the least stable after losing a proton. C क्या है? C is bigger in size. So ठीक है, it can become puckered or it can become non-planar. Somehow it can lose its energy and become non-aromatic. लेकिन A तो वो भी नहीं कर सकता. A cannot become non-planar, not possible. That's why A is going to be the least acidic. ठीक है? That is why pKa order is going to be the opposite. A is greater than C greater than B. तो आंसर B होगा ना? एलिमिनेशन मेथड से भी कर सकते हैं. डेफिनेटली A is going to be least acidic and most basic. तो उससे आपके दोनों ऑप्शन गए और ये दोनों ऑप्शन बचे B and D. ठीक है? And then moving onwards, you know that B is going to be most stable and it will have the least pKa. तो A और B को देखकर ही आंसर आ जाएगा, even if you are not sure about C. So second one is the correct answer, guys. But you know it's that कि कई बार ऐसा हो जाता है कि दो ऑप्शन देख के आंसर आ गया, कई बार होता है कि नहीं भी आया. So just be sure about these basic things. जितनी सिंपल चीजें हमें आती होगी उतना ही अच्छा होगा. चलो next question. According to Huckel's rule, which of these is going to be aromatic, non-aromatic, or anti-aromatic? Alright, बहुत basic question है ये. Yes. Why is it easy? Because a boron has a vacant p orbital. So basically, if somebody is connected to boron, which means that we can consider a carbocation, isn't it? क्योंकि boron के पास भी vacant p orbital है, carbocation also has a vacant p orbital. That's why it can do resonance within this boron atom also. So this molecule is just like the tropylium cation. And you know tropylium cation is aromatic in nature. Tropylium cation कैसा हुआ? ऐसा. This is aromatic. And a boron is equivalent to a carbon having a positive charge. तो ये तो aromatic है. What about this? Again, nitrogen has a lone pair. Okay, nitrogen has got 3 bonds. It has got a lone pair. और lone pair फिर से resonance कर सकता है यहाँ पे. So once we do the resonance, there is going to be a double bond over here. Actually, these questions are very simple. इतना simple होता नहीं है. क्यों? क्योंकि हमने पढ़ा है inorganic benzene के बारे में. ये कैसा बॉन्ड है? बोराजीन जैसा है ना, just like borazine. So borazine is not completely aromatic because the bonds are localized. Even if उसमें डबल बॉन्ड कैरेक्टर है, इलेक्ट्रॉन डेंसिटी है, बट पूरा डीलोकलाइज नहीं है. वैसे ही दिस डबल बॉन्ड इज गोइंग टू बी लोकलाइज्ड ऑन द नाइट्रोजन एंड बोरॉन, बट इट इज नॉट एंटी एरोमेटिक एट लीस्ट. तो ये तो गलत हो जाएगा. इट इज गोइंग टू बी ऑप्शन नंबर 2. दे आर एरोमेटिक but not as aromatic as naphthalene, if in future there is a question like this. Okay, right? चलो अच्छा, बहुत इजी. अब सारे इजी क्वेश्चन है. न्यूक्लियोफिलिसिटी ऑर्डर, increasing nucleophilicity order, very simple. यस, ये किस पे डिपेंड करता है? Order of nucleophilicity will be the ability to give its electron density to another carbon across the period. Yes, electron negativity increases. Yes, guys, everyone has to answer nicely. देखो, सोचो इसके बारे में थोड़ा. Think about it. Okay, do you remember the pKa value? pKa value we had actually compared. ये जो वीडियो बनाया था pKa concept, pKa value of methane, pKa value of ammonia, of let's say it is OH minus, let's say it is coming from water after the loss of a proton, and F minus is coming from HF. ठीक है, तो ये सारे क्या है? Conjugate acids of these anions which are given. ठीक है, so CH4 is going to have pK value from 48 to 50. 48 से 50 रहेगा. So let's say I'm writing 48. This is the pKa value. For ammonia, ammonia is also a poor acid, so it is going to be around 35 for ammonia. For water, it is going to be 16, and for HF, it is going to be around 3. Okay, 3 से 5 के आसपास था वो. ठीक है. So this is the pKa order. Now, if I'm asking you the same question regarding basicity, अगर मैं same question basicity के लिए पूछ लूँ, that what is the order of basicity, so I have already told you that pKa is directly proportional to basicity of conjugate base. तो अगर मुझे पता है, if I know that methane over here is the poorest acid, it is the poorest acid because it is having the maximum pKa value, which means its conjugate base, which is the methyl anion, this is going to be the best base, isn't it? तो basicity का order reverse रहेगा. This is going to be the best base because it is more unstable, क्योंकि कार्बन की electronegativity कम है. Fluoride is most electronegative, so this is going to be least basic. The same order applies for basicity, and the same order applies for nucleophilicity. दोनों में difference क्या है? Basicity और nucleophilicity में difference क्या है? एकदम basic सा difference है, that a base is someone who is looking for a proton, and a nucleophile is someone who is looking for a carbon. So nucleophilicity applies to the power of attacking on a carbon. Basicity applies to the power of attacking a proton. बाकी जो इसकी tendency है वो तो same रहेगी ना, based on its pKa value. So the answer will remain A. Got it? Same order for basicity, same for nucleophilicity. Yes. एग्जैक्टली, बेस की एफिनिटी होती है प्रोटॉन के लिए, न्यूक्लियोफाइल की एफिनिटी होती है कार्बन के लिए, बट अब इनकी इनहेरेंट प्रॉपर्टी जो है वो तो सेम ही रहेगी ना दोनों के लिए. ओके, चलो, नाइसली अंडरस्टूड दिस वन, वेरी बेसिक क्वेश्चन. अब चलते हैं आगे. अरेंज द ऑर्डर ऑफ इलेक्ट्रोफिलिक अटैक फॉर द फॉलोइंग कंपाउंड्स. All right, so this is easy. Order of electrophilic attack. कहाँ हो रहा है इलेक्ट्रोफिलिक अटैक? Yes. Thank you, Deepak. I hope you are doing good as well. Yes. Okay. According to negative hyperconjugation. अच्छा, नेगेटिव हाइपर कंजुगेशन क्या होता है? Yes, electrophilic attack. Who is attacking this ring? Electrophile is attacking this ring, isn't it? Yes, electrophile attack कर रहा है, which means it is giving electron density like this. Right? Isn't it supposed to be like this? According to electronegativity directly attached to carbon. अच्छा देखो, इलेक्ट्रोफिलिक अटैक बोला है, मतलब कि इलेक्ट्रोफाइल इज बीइंग अटैक्ड. ठीक है, तो रिंग पे आया पॉजिटिव चार्ज. नाउ व्हाट? Electron density will be withdrawn outside the ring. Outside the ring, electron density will be withdrawn very nicely with this. अच्छा ठीक है, अब अगर हम इसको let's say इसको हम remove करते हैं CF3 minus, तो CF3 positive is the worst carbocation. It is not going to happen. All right, this is not going to happen because ये इस तरीके से stabilize नहीं कर सकता है, isn't it? Fluorine can't even do resonance. What else can we do? If we have, let's say, the same electrophile attacking over here, then we can make this group leave with the positive charge. That is possible. So इसका आंसर ये हो सकता है option number B, where this is going to be leaving easily, or basically it is more electropositive group as compared to this. This is more electronegative. Okay, so the answer is option number B for this one. ओके चलो, लेट्स मूव ऑनवर्ड्स. लास्ट क्वेश्चन करते हैं हम आज का. ये देखो, कंसिडर द फॉलोइंग कंपाउंड्स. ये आज का लास्ट क्वेश्चन है. ओके, सो विच ऑफ द स्टेटमेंट इज ट्रू रिगार्डिंग दीज मॉलिक्यूल्स? Alkaline hydrolysis. All right, guys. So what do you think is the answer to this question? बहुत ही सिंपल सा क्वेश्चन है ये भी. थोड़ा सा हमें स्टीरियो के बारे में देखना है, isn't it? All right, let's see. Yes, option number D. Which of the following statement is true? So alkaline hydrolysis of B is faster than that of A. ठीक है, चलो ट्राई करते हैं. Alkaline hydrolysis, OH minus is present. ठीक है. In C, nitrogen lone pair not conjugate with carbonyl. Yes, basically it is like this कि alkaline hydrolysis में which reaction is going to be faster. यहाँ पे भी ये resonance कर रहा है, इधर भी ये resonance कर रहा है definitely. What is the effect of having this three-membered ring? Alkaline hydrolysis is basically like this, right? Getting an intermediate in this way. So what is the difference in A and B? इन दोनों में क्या difference है? Let's say it is like this. Yes. Yeah, why? Yeah, Dipanshu, but why faster? Which one is faster and why? Yes, ये last question है हमारा, इसको थोड़ा अच्छे से करते हैं. Smaller ring, more S character. So you mean to say that A is going to be faster than B? Is that so? कि A का reaction fast होना चाहिए B से. हाँ अंकित, कोशिश तो वही कर रहे हैं, अभी प्रैक्टिस ही चल रही है, लेकिन आज का टॉपिक जो है हमारा वो बेसिक टॉपिक है, तो हम लोग यहाँ बेसिक की बातें कर रहे हैं ज्यादातर. ऑल राइट. यस. Yes, so if that is so, rate of alkaline hydrolysis of B is faster than that of A, तो इसको wrong करना पड़ेगा हमें. Also because ये जो है, this is going to leave better as compared to NH2 minus. All right. So yes, what happens in option number C? C में क्या हो रहा है guys? ये देखो, ये strained है. This is strained, and if we are let's say putting OH minus over here, तो ये ज़्यादा आसानी से निकल सकता है. C is going to be faster than that of D. Why? Because of strain only. So और कुछ हो ना हो, ये तो correct है बिल्कुल. Can we say that? This is going to be faster than that of D. Can we say that? Why? Because D is not strained. A six-membered ring is considered to be a stable ring. Right? तो इसीलिए D is going to be the correct answer. Right. Okay. So guys, अब मुझे आप जल्दी जल्दी suggestion दे दो. What do you want in the next session to be? Next session में आपको क्या चाहिए? Do we need practice? Do we need something else? Tell me quickly. Yes. Question का batch. सी अभी अंकित एक क्रैश कोर्स पे काम चल रहा है. इट इज अबाउट लेट्स से शॉर्ट वीडियोस, ब्रीफ वीडियोस, स्पेसिफिक टॉपिक्स, एंड उसके साथ असाइनमेंट्स, उसके साथ में डाउट क्लियरिंग. तो काम उसी पे चल रहा है अभी, बट इट इज गोइंग टू टेक सम टाइम. न्यू क्वेश्चंस, definitely this one was a new question. Right? ये आपका ये जो क्वेश्चन है ये डायरेक्ट किताब से आया है, कैरिसनबर्ग से आया है ये क्वेश्चन, राइट? सो इट्स गोइंग टू बी अ मिक्स. You will have some questions from the book, and your PYQs are very important. They are very potent. They have the highest potential. 2018 to 2023 mixed practice वो भी कर लेंगे. No issues. Yes. Just right. Just after this one, we are going to first do stereochemistry, retrosynthesis, and photochemistry next. Actually, retrosynthesis topic is not directly asked in CSI net. इसलिए हम थोड़ा सा रेट्रो को इतना ज्यादा नहीं देते हैं. एकदम बेसिक सी चीजें आती है, सिंथॉन और ये सभी आते हैं, राइट? मोस्टली द बेसिक स्टफ इज बीइंग आस्क्ड, राइट? So yes, Ganesh, photochemistry we are going to do eventually, but first after this I am planning to do stereochemistry practice. What do you say? Shall I ask you dynamic stereochemistry? Yes or no? इसके साथ में कौन कौन है मुझे लिख के बता दो, yes or no. Dynamic stereochemistry. इसके नाम से ही ऐसा लगता है ना, ऐसा डायनामाइट फटने वाला है. So सभी नेट के क्वेश्चन सॉल्व हो जाए. एक एम आई एम एक्चुअली डूइंग दैट, बट वो इवेंचुअली आएगा. पहले हम बेसिक पे काम कर रहे हैं, तो इसीलिए स्टीरियो आ जाएगा पहले, जीओसी आ जाएगा, राइट? एनएमआर विल कम, यस हारिनी, एनएमआर विल कम, बट आफ्टर अ while. First we are starting from the basic, so we will tend to do dynamic stereochemistry questions. No, Akash, I'm not doing PhD now. No, no. It's not necessary to do PhD after qualifying net. It's your choice. Name reactions. Okay, okay. Name reactions, I will try to complete my playlist, but one by one, because अब जो latest questions है, जो भी मुझे लग रहा है important topic है, those things I will add, so it is going to be one by one. Okay, so yeah, name reactions are many. I will keep on adding one by one. Sequence में best रहेगा, absolutely, because first basic and then we move onwards to the higher level topic. So yeah, tomorrow another session on dynamic stereochemistry around same time 6 p.m. चलेगा? अब timing यही रहेगा guys, 6 p.m. is the time. Yes, Ganesh, if you are getting fellowship, then why not? If you are getting a fellowship, then it's a good option. Yes, absolutely, Priya. That is why tomorrow we are going to do dynamic stereochemistry. And that is why I am discussing and informing all of you, kyunki you will be able to revise, you will be able to collect your knowledge on this topic, and then only we are going to do practice. Okay? No, KV, I am not teaching on an academy anymore. 20th of October was my last session, and now we are going to continue over here. Okay? Yes. All right. Okay, Navneeta, eventually those questions will appear also, because ultimately we are here to practice. There will be many questions, so these questions will also appear. Also, guys, yes, I know that all of you are there on Telegram, so don't miss this out. If you have any questions, if you have questions at all, send those questions to me personally, and I will create one live session, which is going to be our doubt session. तो हम ऐसा कर लेते हैं कि once in a while let's have a doubt live session, so that I am able to solve your doubts for free. So message me on Telegram your doubts. Where are you going to message me? Me personally. Direct message on Telegram. Okay? All right. Chalo. So that's it for today, guys. And we have a lot to learn. और बहुत सारा प्रैक्टिस भी करना है. आई एम गोइंग टू सी यू ऑल टुमारो 6 p.m. Thank you, Ganesh. Thank you, everyone, for joining up, guys. And I'm very positive that you're going to crack the exam this time. And I'm making efforts for that. You are making efforts for that. So definitely it's going to work. And I'll see you all tomorrow. Okay, so have a nice evening and bye, everyone.